Hello, and welcome to Stretchy Math. Today, we are learning about scientific notation. As you know, there are many different ways to represent numbers. Take, for example, the number on the screen. Right now, it is written in numericals. However, I can also write it as 534 trillion. Notice that both of these ways of writing this number are long, and it can be tiring to write long strings of zeros if you are working with lots of big or small numbers. To address this problem, we have scientific notation, a different way of writing numbers. The idea behind scientific notation was developed by ancient Greek mathematician Archimedes, who calculated the number of grains of sand in the world was 1 followed by 63 zeros. In scientific notation, we write this as 1 times 10 to the power of 63. This is much easier to write. Numbers in scientific notation are written as a number between 1 and 10 multiplied by a power of 10. For example, 3 times 10 to the power of 7, or 9.2 times 10 to the power of -4. Be careful with this definition. 61 times 10 to the power of 5 is not scientific notation, because 61 is greater than 10. On the other hand, 0.0004 times 10 to the power of 2 is also not scientific notation. The reason why we multiply by a power of 10 has to do with place value. Remember that our Hindu-Arabic number system is base 10, so the power of 10 indicates what place value the number is. Let's look at an example. 3.0 times 10 to the power of 1 is 3 times 10, which is 30. This means that the 3 is in the tens place because 10 is to the power of 1. We can also see that if we move the decimal one place value to the right to get 30 again. What about 4.6 times 10 to the power of 6? In this case, the 4 should be in the millions place, so we move the decimal to the right 6 places. If the power of 10 is negative, then we move the decimal to the left because negative exponents are a different way of writing decimals. So 2.7 times 10 to the power of -2 becomes 0.027. This helps explain why the number we multiply by a power of 10 has to be between 1 and 10. If we try to take 32 times 10 to the power of 3, we would expect the 3 to be in the thousands place. However, it does not belong there. To write this number in place value form, we can still move the decimal to the right 3 places, as multiplying by powers of 10 will still change the place values of the number by the power of 10. To convert this to scientific notation, we figure out that we have to move the decimal 4 place values to the right to get 3.2, which is between 1 and 10. So this number is really 3.2 times 10 to the power of 4. As you might have guessed, scientific notation is especially important in the sciences, where we are often working with very large or very small numbers. For instance, the mass of the sun is 1.989 times 10 to the power of 30 kilograms, while the diameter of the molecular oxygen you're breathing is 3 times 10 to the power of negative 10 meters.